Welcome back. Welcome to the second half of the school year. We are now starting our marking period 3, and our first lesson is going to be introductory to quadratic functions. Today is January the 8th, and today you're going to learn the characteristics of quadratic functions. You're also going to learn how to describe the changes in the graph when there are changes in the a value of the quadratic function. I'll explain what that means as we continue here. Now this slide has a lot of information, but it's pretty self-explanatory, but I'm going to go through it anyway. So the standard form of a quadratic equation is y equals ax squared, the squared is important, that tells you that it's quadratic, plus bx plus c, where the value of a cannot be 0. So if you're looking here, when we do the function, this value can't be 0. This is just basically the structure of this quadratic equation. These variables are the letters. They will be replaced with numbers. A quadratic function, it creates a parabola. A parabola is this U shape here. This is called a parabola. So let's go through some of the terms that you'll be using in this unit. So I'm going to go from left to right. And we've done this before in linear equations or functions. But here we have the y-intercept. Remember, the y-intercept is where that shape crosses the y-axis. So it's pointing right to 3. It points when y equals negative 3. That's the y-intercept. The x-intercepts. Now, this is a parabola. So notice the x-intercepts is where the line or the shape crosses this x-axis here. And since it's a parabola, it's going to cross it in 2 places. It's crossing here, and it's crossing here. So one of your x-intercepts is going to be negative 1. The other one's going to be a positive 3. The vertex. This is the vertex. So the vertex is the lowest point on this parabola. So if you look at this parabola, if we're going up and down, this is the lowest point on the parabola. So the vertex would be 0, negative 4. That's where it touches. The axis of symmetry is kind of related to the vertex. So this is the axis of symmetry. The axis of symmetry is an imaginary line that cuts this parabola into 2 equal parts, this side and this side. So the parabola actually runs right through the vertex of the shape. This is just reiterating the previous slide. It says the x-intercepts, they're also known as zeros or solutions. They are at the points in which the parabola intersects the x-axis. Again, here and here. Those are the x-intercepts. Then the vertex is the lowest or highest point on a parabola. This parabola is going like this, which is like a U shape. So this particular vertex is going to be the lowest point. If this parabola were to look like, let me see if I can draw one here for you. If this parabola were to look like the opposite of this, if it looked like this, then your vertex would actually be here, because that's the highest point on the graph. But since this original one had the U shape, it's going to be on the lowest point. So this is the high point. If the parabola goes this way, the parabola goes, say that again. So if the parabola goes this way, the high point on the graph is the vertex. If it goes like this, the vertex is going to be the lowest point on the graph. The axis of symmetry, again, like I said, that's this imaginary line that splits the parabola into 2 equal parts. And that's gonna, it doesn't matter if it's an upside down U or an actual U. Wherever that line, imaginary line, splits that parabola into 2 equal parts, that's going to be your vertex. I mean your axis of symmetry. Axis of symmetry. So on our first slide, we talked about how we can tell or how we can describe what happens to the shape on a graph when the value of a is changed. So if you look at the standard form of the quadratic function, you have ax plus bx plus c. The value of a, here, this is what we're talking about. When that value changes, remember the value of a has to be more than 1, and it can't be 0. So when that changes, something happens to the parabola. The parent function is f of x equals x squared. And here, there's nothing here, but we can change that because this is just telling you that could be any number. That variable a could be any number. So for this particular example, let's read this. It says any change in a will create a vertical stretch, vertical compression, and or a reflection over the x-axis. So now we're looking at the value of this a. So if the value of a is greater than 1, the graph is going to stretch upward away from the x-axis. If the value of a is greater than 0 or less than 1, meaning it's a decimal, the graph will compress toward the x-axis. If a is less than 0, the graph will be a combination of a vertical stretch or compression with a reflection. And we'll show you what that means in a little bit. On this slide, it's going to give you a little graph here. So again, if we review, this is the quadratic function ax squared plus bx plus c. The parent function is fx equals x squared. I put this little line here again just to show you that this is what we're going to be changing. So here, the parent function, just like up here, it's f of x equals x squared. If you type that in the calculator, you're going to get a parabola that looks like this, like the red one, right? So then we're going to change that a value, again, this part right here, the number that's right in front of the x squared, we change it to a number that's greater than 1. So 5 is greater than 1. Again, this is a random number that I chose. So 5 is greater than 1, so we put f of x equals 5x squared, and it's going to create a parabola like this. And what happens is, just like we talked about before, it says the change will create a vertical stretch, a vertical compression, and or a reflection over the x-axis. So let's label the axes right here so we can know. So this is the x-axis here. And again, this is the y-axis. So what do you think is happening here? If you're looking at this function here, it looks like the parabola is doing what? It is stretching vertically, meaning it's going up and down. It's stretching vertically away from the x-axis. That's what you're going to see here. In this example, the value of a is greater than 0 and it's less than 1. And like I said earlier, that number has to be a fraction, a decimal. So this is the parent function again. We put this in the calculator or put it in decimals or the TI Inspire calculator. You get your graph. It's going to be this red line right here. It's going to look like this. So if we use a number that the value of a is going to be greater than 0, less than 1, we use a decimal, 0.5. Again, this is just a random number that I selected, but it is a decimal number. So if I put f of x equals 0.5x, it's going to create this green line here. So if you look at the green line in comparison to the red line, what's happening? It is compressing. Compressing means it's going down. So it's compressing toward the x-axis. So let me label these again. This is your x-axis and this is your y-axis. So if you compare the two, when you use a number that is between 0 and 1, which we did, which is a 0.5, it makes the parabola compress closer to the x-axis. And finally, our last example today is going to be when a is less than 0. So when a is less than 0, we're going to be looking at negative numbers. So when we punch in this parent function, f of x equals x squared, is going to give you this parabola. when we give it a negative number in front of value of a is a negative number, we'll say f of x equals negative 1x squared. And what that does, it creates an identical parabola, but it reflects over the x-axis. So again, I'll label these axes so you can know what they are. This is x-axis again, this is y-axis. So you just have to remember when that value is less than 0, meaning a negative number, and this number is random, like I said, you could have put negative 3. So I picked negative 1, and it reflects, like you're looking in the mirror, over the x-axis. Now, the reason it looks like it's identical, because remember what I told you before? When there's no number in front of the variable, it's understood to be a 1. So if I had a 1 here and negative 1, they're kind of the opposite of each other, so they're basically going to be the same shape. It's just going to reflect. This is a positive one, this is a negative one. And that's all it's showing you. So today you learned the characteristics of a quadratic function, meaning the parts. It's ax squared plus bx plus c. And then you described the changes in the graph when the changes in the a value occur in that quadratic function. In the following days, we're going to be looking at values a, b, and c. We're going to change those and we're going to see what they do. But today I just wanted to introduce you to this part, just giving you that first change. So that's all we're doing today.